Like Admiral Sharp, this is my first GEOINT, and I know it won't be my last. It's a huge honor to be able to address you today. The more I learn about the U.S. Geospatial Intelligence Foundation's mission, the more I realize how important it is for the future of land, joint, and coalition warfighting. I don't need to tell anyone here how much fun it is to be in San Antonio. I'd also like to thank Chairman, the Honorable Jeff Harris, from the NGA, Vice Admiral Sharp, and Major General Cleveland, and of course the entire support staff for making this an amazing and professional event. Thank you, the Honorable Lisa Porter, the Honorable Carrie Binging, the Honorable Sue Gordon, for your continued support to the warfighter. What I'd like to talk to you about today is the Army's modernization efforts related to geospatial intelligence. In order to do that, I'm going to share how we see the future battlefield, what some of our core requirements are in the GEOINT area, and some of the impending projects we're working on. I'm going to keep it fairly short as I want to have plenty of time for questions at the end. The future operational environment and the changing character of war presents our nation and our armed forces with many challenges. The demands on Army modernization across the full range of capabilities and functions as part of the joint force and interoperability with our allied and partners. The stakes are high and time is not on our side. We need to modernize, but our challenge is specifically how, what concepts, capabilities, and formations should we develop and why? The key to answering these questions is understanding the changes that have occurred and are continuing to occur in the character of war. Change is the only constant when the character of war is concerned. The character of armed conflict has shifted many times over the centuries. Gustavus Adolphus transformed the character of war by professionalizing the Swedish army and creating combined arms effects between artillery, infantry, and cavalry in the early 1600s. The French Revolution created the concept of levy en masse to mobilize the entire people and economy of a nation-state to wage war. World War I forced armies to transform every level of their formations, from squads to division and corps headquarters, to be able to fight with intensity, complexity, and lethality of automated weapons. World War II took war to an industrial scale. And even in the 1980s, the United States Army transformed warfare with the doctrine of air-land battle. Over my career, there have been incredible revolutions in military affairs, to include precision-guided weapons, GPS, stealth technology, and a small thing called the internet. But these are only accelerating in the 21st century, and the US needs your help to innovate to how to adapt all aspects from doctrine and training to organization and technology solutions. The nature of war, which Clausewitz defines as an act of force to compel the enemy to do our will, remains constant. War remains an inherently human, an inherently political, and an inherently violent endeavor. It is important to take the moment to appreciate this reality, particularly in the context of human-machine teaming. War will continue to be based around imposing our will upon a human adversary or changing the adversary's calculus. It will be waged nowadays, ever more than ever, in the arena of human perception, as well as on an increasingly complex, urbanized, and lethal battlefield. An environment already populated with hyper-precision weapon systems and amazing ISR assets. Soon this environment will be populated with even more precision long-range systems and even hypersonic and directed energy weapons. With artificial intelligence, not only will the speed of battle become increasingly fast, but AI-enabled ISR systems will make it difficult to hide military formations for very long. We are an ethical force that strives to hold our American values. I can't think of a more powerful argument for humans in the loop than this. However, as Clausewitz points out, how war is carried out is shaped by what he calls the spirit of the age. It is in this area that the character of war is changing. Our adversaries are seeking to leverage emerging technology and deploy capabilities that challenge our forces through multiple layers of standoff in all domains: space, cyber, air, land, and sea. We can no longer expect to face these threats only on enemy terrain, but must also be prepared to fight and defend in our homeland. We now face defeating multiple layers of anti-area, anti-denial systems, or A2AD, in all domains, in order to maintain the coherence of our operations. As challenging as A2AD strategies and capabilities are, they are just a symptom of larger changes to the character of war in the spirit of the age of the early 21st century. On the future battlefield, these changes translate into unprecedented speed, scale, and lethality that spans the physical, virtual, and cognitive domains. As I think about this, I can clearly imagine a future battlefield where intelligence enables the US joint forces to perceive, decide, and act across the full breadth of military activities at what my boss likes to talk about the speed of relevance. This must be faster than any potential adversary. In fact, the speed of decision, which will start to be measured in seconds, will be a critical part of any new offset strategy. Geospatial intelligence must be prepared to visualize, analyze, and predict battle space activities to support our military leaders at the point of decision. These intelligence activities will take place in a challenging, conflicting environment in which the volume, diversity, and velocity of raw data and available information currently would overwhelm our service members, civilians, and systems. Furthermore, adversarial misinformation campaigns and cognitive warfare will attempt to target, confuse, and shape our will and ability to act. Cyber attacks will bedevil military operations from home station through deployment, onto the battlefield, and even into the foxhole. Every attempt to communicate, whether between our joint force and unified mission partners or between squads, will face jamming and spoofing. Ironically, Clausewitz's cloud of war, or fog of war, might prove to be thicker in the digital age than it has been since his own time. While our recent low-intensity conflicts were characterized by localized interaction, future conflicts will likely be overshadowed by the threat of deep fires. Long-range weapons will strike accurately at tremendous distances, enabled by ubiquitous sensors looking for you from outer space, down to micro drones under leaf and a hacked smartphone feed. There will be no rear area, not just because of insurgents, but because our adversaries are working diligently to find and target our forces and homelands with strikes by long-range fires from over the horizon. GEOINT is critical for developing that foundation military intelligence that enables artificial intelligence technologies to monitor the myriad of real-time feeds to discover, find, fix, track, and ultimately destroy these threats. Human-machine teaming is critical to ensure the targeting process follows the values of our military and adheres to the laws of armed conflict. In this environment, large, slow formations and static positions are targets waiting to be destroyed. The Chief of Staff of the Army, General Milley, once stated that if you stay in place for more than 2 to 3 hours, you will be dead. Mobility and speed will be key to surviving, as will the ability to rapidly deliver precise, lethal effects of our own. Underpinning the concept at the very core is GEOINT. We have to operate widely dispersed, but able to mass and then disperse again. But where will we disperse to? Along which routes? What are the threats and obstacles along the way? How will the enemy react if commanders choose one course of action over another? Can we start to target those areas before they get there to return fire? We must continue to build decision support systems to not only help answer these questions quickly, but also get to the information to the correct user in a bandwidth-constrained environment. These AI decision support tools require on-demand, real-time access to assured GEOINT to perform this analysis in seconds to support our planners. Autonomous and optionally manned systems will play a critical role in gathering geospatial information on the future battlefield, and this information will become increasingly perishable. These systems rely on AIs to support optimization of flight paths, cross-platform dynamic tasking, and smart filtering of the massive amounts of data. We must develop metrics to analyze tools to understand when these systems will work well, when they are brittle, and when they are susceptible to adversarial AI attack. We must also be prepared to operate in an environment where we ourselves are continuously monitored by our adversaries' GEOINT capabilities. Just as we have honed our operational security and our counterintelligence functions for the traditional battlefield, we must update these concepts for the age of artificial intelligence and think hard about counter AI to spoof pure adversarial GEOINT systems to cast the fog of war upon them. So the question I asked at the beginning, this future conflict, different in character from which we have even known over the past decade, is why we need to modernize. But how should we do so, and what new capabilities and organizations we need? The Army Futures Concept Center, led by Lieutenant General Eric Wesley, has done a fantastic job laying out what this future conflict looks like and a conceptual approach we need to be able to operate this environment. I've got a short video here to show you from General Wesley's team.
The history of the United States Army has shown a force continually driven by change. In the 21st century, our Army continues this change by creating new capabilities, organizations, and approaches to deter conflict. When required, we strive to transition rapidly to conflict and prevail on an increasingly complex, lethal, hyperactive, and urbanized battlefield. Leading this change, the Army Futures Command has developed a new concept, the U.S. Army and Multi-Domain Operations 2028. This concept describes how Army forces, as part of a joint interagency and coalition team, address the implications of large-scale ground combat operations and the problem of increasingly capable anti-access and area denial, or A2AD systems, employed by our adversaries to generate effective standoff. Army forces conduct multi-domain operations to defeat this standoff. They operate across all domains and within contested spaces to overcome an enemy's strengths by creating multiple simultaneous operational or tactical dilemmas. This is accomplished through the application of calibrated force posture, multi-domain formations, and convergence of capabilities across all domains. Applied together and over time and spaces, they enable the Army and Joint Force to defeat an adversary's A2AD systems. Multi-domain operations addresses standoff in both competition and conflict. Over the last 2 decades, Army forces oriented on counterinsurgency operations, placing little emphasis on large-scale combat. At the same time, China and Russia fielded robust A2AD systems that create political, physical, and functional standoff. In competition and conflict, their increased capabilities in both the cyberspace and space domains, combined with weaponization of the information environment, extends standoff, reducing friendly forces' speed of recognition, decision, and reaction. This contributes to increased risk of unacceptable losses to U.S. and partner forces. Our adversaries use standoff to separate the elements of the joint force in time, space, and function. The previous deep, close, rear battlefield architecture is too limited in scope to effectively describe the multi-domain operational environment. It fails to adequately describe the increasingly contested character of the operational environment across the depth of tactical, operational, and strategic areas. These shortfalls drive the requirement for a new framework, one that accounts for operations in all time periods, in all areas, and across all domains. Importantly, it places just as much emphasis on competition as it does on conflict. Army forces conduct multi-domain operations to defeat the adversary's standoff by competing short of armed conflict. When necessary, Army forces rapidly transition to conflict and penetrate and disintegrate enemy A2AD systems. They subsequently exploit opportunities to achieve strategic objectives and force a return to competition on favorable terms. In short, the answer to the problem of an enemy's layered standoff is to compete, penetrate, disintegrate, exploit, and recompete. Army forces compete below the threshold of armed conflict. Together with joint forces and interagency partners, they expand the space in all domains by enabling the defeat of information in unconventional warfare, conducting intelligence preparation of the threat's long-range systems, and countering its reconnaissance, and by demonstrating a credible deterrent. In competition, Army forces leverage calibrated force posture to deny the adversary's establishment of A2AD standoff, deter fait accompli campaigns, and set conditions for friendly formations to rapidly seize the initiative if conflict occurs. In conflict, Army forces penetrate and disintegrate the enemy's anti-access and area denial systems. Despite limited warning, Army and joint forces rapidly transition to conflict and converge capabilities to penetrate and begin the disintegration of enemy long-range systems from both within and outside of established standoff. Multi-domain formations at echelon, including brigade combat teams, divisions, and corps, expand these penetrations and place enemy formations in positions of relative disadvantage. By disintegrating the enemy standoff, friendly forces collapse both the enemy's capability and will to fight, enabling exploitation. Army forces exploit opportunities to defeat the enemy and achieve their objectives, setting the conditions for a return to competition on favorable terms. In multi-domain operations, convergence is the arrangement of capabilities across all domains, environments, and functions of time and physical spaces to gain overmatch. This enables Army forces to exploit the disintegration of the enemy systems and gain freedom of action, dictating the pace and tempo of operations. Future formations achieve convergence by increasing the pace and agility of operations and accessing joint, inter-organizational, and multinational capabilities at lower echelons in new ways. Emerging technologies and processes enable friendly forces to evolve from episodically synchronizing multi-domain effects today to leveraging continuous integration tomorrow. The U.S. Army in Multi-Domain Operations 2028 concept describes the fundamental changes needed to address the emerging challenges of the 21st century. Leveraging capabilities across multiple echelons and domains, this concept drives Army modernization through 2028 and into the future.
I want to thank General Wesley's team for putting together such a great kind of overview of MDO operations. And if you haven't had a chance to read it, it's available on the web and you can get it off Army website. The multi-domain operation concept details how the Army continuously and rapidly achieves convergence of cross-domain capabilities to defeat an enemy's efforts to create standoff. Army forces, as part of the Joint Force, will execute multi-domain operations to prevail in competition below the level of armed conflict and win in combat if necessary. In multi-domain operations, Army forces enable the Joint Force by penetrating and disintegrating enemy anti-access and area denial systems. They then exploit the freedom of maneuver to achieve strategic objectives and force a return to competition on favorable terms. Multi-domain operations effectiveness helps deter conflict, which is our ultimate goal. So what is the role for the GEOINT community in all this? Put simply, GEOINT will take a more central and fundamental role than perhaps they ever have before. Multi-domain operations is predicated on the ability to see, understand, and act faster than the enemy, almost literally none of which is possible without a diverse and resilient community of GEOINT capabilities and professionals empowered by modern material capabilities and advanced computational methods. Specifically, here are some of the things we will need. We will need your help to devise individual and collective training. Units from brigades through corps, from national to tactical, must be trained and ready to conduct sustained ground and air, intelligence, surveillance, and reconnaissance operations. These must occur across the range of military operations and in an increasingly urban and complex environment. Increased capabilities to automatically generate high-resolution elevation data off of multiple sensors, both active and passive, which produces data readily ingestible into Army modeling simulation systems of record. This would support quick reaction, rapid, on-the-fly simulations of the battlefield through immersive, augmented reality, or virtual reality type environment at the tactical level. The Army, the most lethal and capable ground combat force in history, will conduct multi-domain operations in an A2AD contested environment. Modernization of our weapon systems, logistical systems, and mission command systems are all underpinned by geospatial foundations. AI-driven modeling and simulation abilities to test and evaluate these systems against the rigors and complexities of the future operational environment are critical to their success. We are also looking at shortening our sensor-to-shooter timelines. We are limited on our manpower as we must focus our soldiers on their warfighting functions. Unsupervised machine learning approaches and synthetic training techniques must advance. We improve our ability to train our target recognition capabilities. Some of the examples might include aided or automated algorithmic extraction of targets from GEOINT sources, sending information directly to pre-prepare our weapon systems, automated target convolution or fusion of information from many data streams to improve the accuracy and confidence of our targeteers. As we heard of from speeches yesterday, standardized formatting and disseminating of GEOINT information system information is critical. However, all these capabilities are just tools, unable to achieve true success on their own in the intrinsically human endeavor of warfare. For this reason, the military must develop smart, thoughtful, and innovative leaders of character. They must be comfortable with complexity and capable of operating from the tactical to the strategic level. Decisions in current and future complex operating environments must be rapid and informed. Therefore, we must provide computational tools to reduce the cognitive burden on our leaders, transitioning from critical thinking to computational thinking. Military decision-making frameworks such as PMEZ-PT, ASCOPE, SWET-MSO require continuous and interactive analysis of hundreds of layers with thousands or even millions of points of data in order to effectively convey a picture of a complex battlefield. These capabilities must include automated terrain recognition and course of action development to help automate the information preparation of the battlefield process so we can close the loop between the intelligence cycle and the operation cycle to make the military decision-making process even faster. We need to be able to get dynamic updates from our systems into our systems of record so our commanders can see a more accurate and common operating picture. And finally, we need to be able to automate and understand the wargaming for these so we can wargame hundreds of different potential warfighting outcomes all on our simulation systems. Again, we require capabilities leveraging a synthetic training environment that supports an effects-based approach and a comprehensive representation of the real world at all levels of granularity. This environment needs to be designed not only to train our human operators, but also our AI-enabled models. The Army's needs in multi-domain operations go beyond this. The Army's current capabilities will likely struggle to meet future demand. There are concerns that this can neither port nor scale to meet the anticipated requirements. With this in mind, the Army is looking at the high-performance computing modernization program, efforts going on at DARPA, at the Strategic Capabilities Office, with our industrial partners and academias to help speed this process. We must focus on creating data to feed current and future AI and machine learning algorithms to ensure the quality, type, and quantity of available data to produce high-fidelity results. Some related recommended requirements include advanced data storage and dissemination and visualization technologies, automated data curation, the ability to take data from multiple domains, securely and efficiently integrate it into a data fabric, and then propagate it to the force. Smart filtering in a growing data-rich environment, the challenge will be how to filter out the noise from the most critical data information for our warfighters. Innovation in high-density storage and data dissemination over limited communication systems. This data must be authenticated and assured. Cloud-based where possible, but capable of operating in a disconnected method when required. The good news is we're working on solutions to these. The Army's intelligence enterprise has devised a framework known as the Mission Command Intelligence, or MCI, to achieve Army intelligence teams capable to support mission command against all threats in multi-domain operations by 2028. MCI aligns intelligence requirements, planning, development, and resourcing efforts with the Army's multi-domain operations concept. It will enable commanders to achieve decision superiority with the speed, precision, and accuracy required to integrate and synthesize combat operations in multi-domain environments. MCI essential components are sensors, data, and analysis enabled by a cloud-based network architecture. These components use advanced technologies and cutting-edge capabilities to empower intelligence professionals to execute doctrinal intelligence processes functions. In the context of multi-domain operations, MCI supports the total Army's effort to achieve convergence in all domains across time and space. Intelligence supports to long-range precision fires, one of the Army's 6 modernization priorities, will incorporate machine learning based on similar commercial applications used in agricultural and geology. It's a matter of training the algorithm to find certain characteristics that enable rapid and precision fires. In addition, we are building an integrated synthetic training environment, or STE, built on standards and shareable geospatial foundations. The STE will provide terrible training solutions for multiple initiatives, from simulation exercises for small tactical units up to wargaming for operational headquarters. The STE will use immersive and interactive tools to expand this training experience. It is critical this environment use as realistic and as up-to-date world data that's available. Artificial intelligence is one of the Department of Defense's digital modernization priorities, and last summer the Department of Defense CIO established the Joint Artificial Intelligence Center. In response to this, and to focus our service-level efforts, the Army established this AI task force operating primarily out of Carnegie Mellon University and the National Robotics Engineering Center in Pittsburgh. From that initial hub, the AI task force will extend the network across academia and the industrial ecosystem. In conjunction with the Army Research Lab, we are establishing an Army AI testbed and reviewing policies that could inhibit machine learning, deep learning, and automation across the service. Perhaps more importantly, we are developing a talent management plan to enable the Army to hire, develop, and retain the necessary skill set to support AI development into the future. We are also working with the Army CIO G6 and the network cross-functional team to develop network, storage, and compute requirements to be able to do AI at the edge, to both train new AI models and to conduct the inferencing that's so important. One example of this is the AI-augmented Internet Battlefield of Things, a military twist on the emergency role of AI in managing and employing digitally linked devices in our homes, factories, workplaces, and neighborhoods that has analogous applications on the battlefield. These initiatives are as important as they are exciting. However, we still need your help. The enthusiasm here in San Antonio is palpable. You're in this line of work because you want to make a difference, and you're here today because you want to be involved. We need that enthusiasm because our requirements are significant. We need new geospatial and other intelligence solutions, as well as improvements to existing solutions, and we need your help to apply all these solutions to best effect. We cannot succeed without your support. This is absolutely essential. We want to build, fail, learn, and build again to advance geospatial and other intelligence capabilities into the hands of our soldiers at the speed of relevance. And that is ultimately what this is all about, providing American soldiers, sailors, and airmen with the tools that will guarantee their success in a future conflict, making sure they have the concept, capabilities, and organizational structures they need to be able to fight, defend, and win on a complex, lethal battlefield and bring the service members home. Better yet, these capabilities will ensure such a deterrence effect that we won't have to fight at all, because potential adversaries understand that they will lose and choose not to fight the United States in ground combat. As General Milley likes to say, the ultimate judge of our success will be the men and women of our future Army who will deem the concepts, capabilities, and formations we create to be lethal and effective, or not. Our mission, in fact, our sacred obligation, is to ensure we do not fail them. With your help, I know that we will succeed. Thank you for your time, and if you'd like this talk, please attend Gary Bloom's talk this afternoon on GIS solutions in support of the Army Modernization Enterprise. I look forward to your questions.
Thanks, Matt, so much.
Thank you.
So the Army's got a little bit on its plate. Some good questions here have come in. This one's about urban and complex terrain. How's the Army preparing for the subterranean domain, especially against tactical tunnels from non-state actors? How do we help commanders understand understand the threat? Again, it could probably be beyond just underground, but urban and complex.
Sure, the urban complex nature has lots of underground systems. I've seen a lot of great demonstrations yesterday of some of the abilities that some of industry has already created. I've seen other systems where industry is creating small UAVs with LiDARs on them to scope out and map out some of these terrains. But it's going to be a multi-solution. I mean, we need to prepare the battlefield, understand the existing kind of infrastructure in all major cities to create that extra space, as we know that some of our surveillance systems can't see as well. And that, again, kind of keys to why we have to prepare for the potential future conflicts today.
So given all that you do have on your plate as evidence during your remarks, what would you identify as the top AI priority for the Army, if you had to pick one?
So the Army likes to, and most modern armies talk about artillery as the king of battle. Artillery is kind of our standoff systems that the Army uses. So support to long-range precision fires is kind of one of the main efforts that we've been focusing on within my team on how to find targets faster. One thing that's happened, or at least I see one of our problems, is a lot of our lower level units are still looking for targets the way they've done for decades. They'll receive some type of geospatial information product. It could be a SAR image, it could be a satellite photo, it could be a UAV feed. They receive that image down. Again, it takes a long time to get that image pushed to them because the bandwidth for our tactical units isn't that great. The operators are sitting kind of off in an intel cell away from the intelligence analysts are sitting off in an intel cell slightly away from the operators, and then they're manually looking through images just the way GEOINTers have been doing it for a long time. I think artificial intelligence can speed that process. I was at the National Training Center a few weeks ago, again, looking at some of the process they were doing, and I had all sorts of Army intelligence analysts come up and show me all the great products they're working doing. And they showed me like a SAR image from the night before that a sensor had taken, and it showed the operational forces there at the National Training Center had drug a new tank ditch through the desert, and they were all very excited. But that time scale is not going to be fast enough for future warfares, because those images are taken hours. It takes huge amounts of time to get that data pushed down to the analyst, then to process it, and then to go over and manually do it. A lot of this can now be done by artificial intelligence agents in a much higher level in the organizational structure of the Army. They can process the data at a local center, look at it, verify the target, and then pass down a much smaller amount of information to the team that actually has to conduct the fire mission. And I think that's a huge win that we can get fast. And then we can expand that to other systems as well, and not just traditional artillery, but kind of all the systems that General Wesley's teams talk about to create this convergence between our air systems, our land systems, and all the different ground systems that we have.
So just a small top
Another
priority.
small tack.
Right. This is sort of at the intersection of the changes fostered by AI and strategy and Clausewitz, perhaps. How do you see AI changing the degree of centralization of command, battle command within the Army? There's a certain amount of centralization for air and missile defense versus something more decentralized in the combat arms, the infantry, armor, et cetera. How might AI change that dynamic?
So as a lot of us have all seen, AI has been kind of transformational in a number of different industries. If you look at the ride-sharing kind of industries and how they've kind of transformed moving people through our cities, they've done that in a much more centralized way. The Navy, as the way they fight a carrier battle group, the way the Air Force fights out of an air operations center is all much more centralized. The Army has a much more difficult environment, though, being on the land. So at times, we're going to need a centralized approach. For our expensive long-range precision fire systems, I can see a much more centralized approach, just like we do already with our air defense systems. But for our more smaller tactical units, our infantry units, our armor units, even some of our shorter range artillery systems, we need to figure out a way to do it in a more distributed fashion, but as well as to understand the effects they're going to get at that local level and how those effects can affect a bigger part of the operation. One key part of that is logistics. So how are we going to use AI to feed logistics, to feed all those different units, to get the right ammunition, to get the right fuel, to get the right water, all the different systems or repair parts that we need in this distributed battlefield. And I think that's another great place that artificial intelligence can kind of have effect, that we can have all these different users across the battlefield, be it a fire mission, a logistics service, or even just crowd control, and how we can use kind of to synchronize those effects better to get the kind of efficiencies that we're seeing a lot in the early 21st century economy.
Well, generally, usually it seems like you are the right person at the right place and time. And we wish you the best of luck and thank you for sharing your perspectives with us this morning. Thank you.
Thank you.